Welcome back, yo. Guess what time it is? It's time to do some more works with fractions, if you know what I'm talking about. Which model is shaded to show a fraction equivalent to 1/4? Now don't be fooled. Just because it has a 1 here doesn't necessarily mean that the one picture with one thing shaded in will be correct. No, you have to think of it more like this. If you cut the whole thing into 4 pieces, would you have 1 shaded in? Now look, this is cut into 5 pieces. This is more like 1/5. And down below, look at that. 2, 4, 6, 8, 10. That's more like 1/10. G is the correct answer. Mr. Graham! That says 1/4, and this has 2 things shaded in, and it's out of 8. That's true. Good eye. You're right. That is 2 eighths. You're right. However, 2 eighths can reduce. Don't you see what it can reduce into? Don't you see just by from the picture? 1, 2, 3, 4. If you divide the top and bottom by 2, divide by 2, divide by 2, you get 1/4, which is just what we wanted. Yeah! Alright, moving on. Remember, with multiplying fractions, you multiply straight across. 1 times 3 is 3. 2 times 4 is 8. Yeah! Filling in the blank isn't that much harder, because you had to multiply straight across. 1 times 3 is 3. Blank times 4 is 8. The blank should be a 2, because 2 times 4 is 8. Did you like that? Should I sing more often? I know I'm not very talented, but I try my best. Anyway, division of fractions. Well, you have a whole number here, but don't worry, because whole numbers can be fractions. Just put the whole number over 1, and it's a fraction. But this is a division problem, so hopefully you remember that when you divide, you actually flip that second number. So that 6/1 gets flipped into a 1/6. You drop that 2/3 and realize that the division sign, only in fractions, division sign turns into a multiplication sign. Multiply straight across. Multiply straight across. 2 times 1 is 2. 3 times 6 is 18. Yeah. That can reduce, by the way. You can divide the top and the bottom by the same number. Usually you want to look at the small number on top. Look, it's only a 2. So divide it by 2. And ask yourself, can 18 also be divided by 2? It totally can. It totally can. 2 divided by 2 is 1. 18 divided by 2 is 9. This is a good answer. This is a better answer. Oh no! We're adding fractions. These numerators are the same. But this guy is not the same. That's okay. We can make them the same. How can a 2 become an 8? Think about it. Through multiplication, a 2 can become an 8 by multiplying it by 4. 2 times 4 is 8. And whatever you do to the bottom of a fraction, you always have to do to the top of a fraction to keep it all balanced and ninja-like. 2 times 4 is 8, which is what we want. We want all of the bottom to be the same, all of the denominators to be the same. And 1 times 4 is 4. Now we can add these up, no problem. 4 plus 7, that's 11. 11 plus 5, that's 16. 16/8 is an ugly fraction, but you can make it more pretty. Ask yourself, should that numerator be bigger than the denominator? Nope! So divide it into the numerator. 8 goes into 16 2 times. Perfectly, with no remainder. So 16/8 can just become 2 wholes. This is a good answer. This is a better answer. You want to be good or you want to be the best? You tell me. I want to be the best. You should too. Word problem. Of the cakes at the Jillian's Bakery, 2/5 have chocolate frosting. Of the cakes with chocolate frosting, 2/3 have raspberry filling. What fraction of the cakes at Jillian's Bakery have both chocolate frosting and raspberry filling? This is hard to tell, but believe me when I say that this is a multiplication problem. How can I tell that, Mr. Graham? How can I tell that this is a multiplication problem with fractions? Well, you've got two fractions, so hopefully you know that much. And they're asking you what fraction of cakes have both chocolate frosting and raspberry filling. I suppose when they give you two things, like chocolate frosting, raspberry filling, and they say what fraction has both, that is your key to a multiplication fraction word problem. That is going to take some memorization skills, because to me that doesn't come too intuitively. But now that we know it's multiplication, figuring it out shouldn't be too bad. 2 times 2 on top, 5 times 3 on bottom, 4 over 15. If we could make this answer more beautiful, we should, but if you think about it, you'll probably see that 4 and 15, they can't be divided by the same thing. 4 can be divided by 2, but 15 can't. 15 can be divided by 3 or 5, but 4 can't. So it's kind of stuck where it's at. Pop guide number 2. Same as pop guide number 1, but with different kinds of problems. Addition of fractions with the same denominator. Multiplying fractions. Dividing fractions. And adding fractions that don't have the same denominator. A little tougher. If they're not the same, remember, you gotta make them the same. Want me to do one for you real quick? Alright, I'll do one for you real quick. Don't tell anybody. 3 and 2 aren't the same, so you make them the same. You can combine their powers by multiplying them by each other. 3 times 2 is 6, so the new denominator for both fractions is 6. But then this has to get multiplied up there. 2 times 1 is 2. And this has to get multiplied up there. 3 times 1 is 3. Now you can finally do the addition that they wanted you to do. 2 6 plus 3 6 is 5 6. That's a beautiful answer. Hi-ya! Alright, don't tell anybody I did that for you, okay? That's a secret. Alright, thanks for joining me, guys. One more video in this series for this week, and I'll see you then. Alright, bye.